Hello, we're going to take a look at section 9.3, which is geometric sequences. 9.2 was arithmetic sequences, which was when the pattern was adding or subtracting by the same number, and sequences just means the list of numbers is separated by commas. Geometric sequence is when your pattern is multiplying or dividing by the same number. And sequences, again, just means that the list of numbers is separated by commas. So for this one, to start off with, I have some examples. We're going to just go through and say yes or no, is it a geometric sequence? Okay, so for this first problem, we have 3, 6, 12, 24, 48. Notice each time they're multiplying by 2. So we would say yes, it is a geometric sequence, and our R represents 2. We're multiplying by 2. And our R just stands for common ratio. As we get further, there's going to be a new equation that I'm going to be introducing to you for geometric sequences. We need to make sure that the R is the number that you're multiplying by. So if the pattern is dividing, I'll show you what you're going to put in for your R. This next one, notice we times it by 2, but we don't keep multiplying it by 2. So we'd say no, this is not a geometric sequence. Hopefully you notice for this one that they're adding 3 each time, so instead this one is an arithmetic sequence and the common difference is adding 3. For this next one, it's 3 to the 5th power, and then 3 to the 10th power, and then 3 to the 15th power, 3 to the 20th power. Notice for this one it is using exponents. So when the bases are the same, you add your exponents. So to go from here to here, if we're multiplying by 3 to the 5th, notice when we're multiplying and our bases are the same, you add your exponents. So 3 to the 5th times 3 to the 5th, we'd get 3 to the 10th. If we then multiply it by 3 to the 5th, notice if we're multiplying and our bases are the same, we add our exponents. So then we would be multiplying by 3 to the 5th again. This next one, if we multiply by 3 to the 5th, notice if our bases are the same, we add our exponents, so it keeps working. So we would say yes, and our common ratio is 3 to the 5th. Now this next one, notice how we are dividing by 2 each time. So whenever your pattern is dividing, like this one we're dividing by 2, your common ratio is then going to be the reciprocal. So we would say that our common ratio, think of this as a fraction, then we take the reciprocal of it. So it is 1/2. So we're multiplying by 1/2. So whenever you see that your pattern is dividing by a number, just put the reciprocal of it, and that is going to be your common ratio. Alrighty. So for this next example, it says find the 10th term of 4, 12, 36. Okay, we know it's a geometric sequence. And so we're going to use this new formula that I have for you. And we can use this formula whenever it is a geometric sequence. So our a to the n, again, just represents what is the nth term. So we're trying to find what is the 10th term in this one. Our a to the 1 is what is our first term. Our r is our common ratio, what are we multiplying by. And our n is the term number that we're trying to solve for. This n minus 1, make sure when you're writing it down that that goes in the exponent spot. Alrighty, so for this problem, we want to find the 10th term, so our 10 represents our n's. So we're going to plug in 10 for both of these n's. Okay, then from there, it says a to the 10, what is the 10th term? We don't know what that is, so we leave that. That's going to be our missing term. Our a to the 1 means what is the first term, so our first term of our sequence is 4. So we substitute that in. Our R is what is our pattern, what are we multiplying by? So we're multiplying each time by 3, so we're going to plug in a positive 3 here. And again, our n is 10. We want to find the 10th term, so 10 minus 1. So then we're going to go through and simplify this down. We can plug this into our calculator just like this. So we're going to do 4, then parentheses, 3 parentheses, and then 10 minus 1, we just get 9. So to the 9th power. And we get 78,732. So if we would keep multiplying by 3, then we're going to get the 10th term is this value. Notice for geometric sequences, our answers are going to be a lot smaller or a lot larger because the pattern, if we're multiplying by a number greater than 1, it's going to increase rapidly. If we're multiplying by a number less than 1, it's going to then decrease rapidly. Alrighty, for this next one we have 2 and then 2 blanks and then negative 54. We want to find those 2 missing terms. So if we can think back to the arithmetic sequences, we're going to use this formula in the similar manner. Okay, so we know the first term, we know the fourth term, so we're going to use that to our advantage. We don't know what the common ratio is, so r is going to be our missing variable. Okay, and we know what the fourth term is, so we're going to use that to our advantage. So our n is going to be 4, so a to the 4 equals our a to the 1 times r, and then 4 minus our 1. And then this a to the 4 means what is the fourth term, so we plug in negative 54. Our a to the 1, what is the first term, so 2. And then we leave our r because we don't know what our common ratio is. And then 4 minus the 1, we get 3. So this is going to be our equation, and then we need to solve for our r. So we're going to divide both sides by 2. Those will cancel out, so we have negative 54 divided by our 2. We get negative 27 equals r cubed. And then from there, we want to go ahead and take the cube root of both sides to get that r by itself. So then we're going to get r equals, and the cube root of negative 27 is just negative 3. So our common ratio is going to be, it's multiplying by negative 3. So if we keep multiplying by negative 3, we're going to get our 2 missing numbers. So 2 times negative 3, we get negative 6. Take negative 6 times negative 3, then we get a positive 18. And if we take 18 times negative 3, then we'd get to negative 54, so we know we have the correct answer. Alrighty, this next one, it just has one missing number. So we have a geometric mean formula that we can be using. So the geometric mean formula is the square root of x times y. So our x and our y are just our 2 numbers that are given to us. This formula only works if we have one missing middle number. So then we go ahead and multiply those 2 numbers. So 3 times 12, and then we take the square root of that answer. So 3 times 12 is 36. The square root of 36 is 6. For these ones, they don't give us enough numbers to know if we're multiplying by a positive 6 or if we're multiplying by a negative 6. Or if our middle number is positive 6 or negative 6. So we're just going to put our final answer as plus or minus 6. That our pattern can be multiplying by a positive 2 and it works out. Our pattern can be multiplying by a negative 2 and it works out. So plus or minus 6 is that missing middle number. Let's do another one like that. So we have 48, then a missing middle number, and 3. So we're going to use this mean formula, so the square root of x times y. So 48 and 3, we're going to plug in for our x and our y. Then we're going to multiply those 2 numbers. We get 144, so we're going to take the square root of 144 and we get 12. So our missing middle number is going to be plus or minus 12. So whenever it's a geometric mean one, then we're going to have that plus or minus sign. So our pattern, notice we are dividing by 4 each time and it works out, or we can be dividing by a negative 4 and it works out. They don't give us another number to tell us if our pattern is a positive 4 or negative 4. So for this, we need a plus or minus sign. Alrighty, for this next one, we want to find the 25th term. So for this one, it goes from 2 to 2/3. Notice we're dividing it by 3. So if our pattern is dividing by 3, our r is going to be the reciprocal of that. So our r is going to be 1/3. So anytime our pattern is dividing, our r is going to be the reciprocal. So our r is 1/3. So we're going to use our formula. We want to find the 25th term, so we're going to plug in 25 for both of our n's. And then our a to the 25 means what is the 25th term. We don't know that. We're trying to solve for it, so we leave that. Our a to the 1 is what is our first term. Our first term is 2, so we can substitute that in. Our r is our common ratio. We're multiplying by 1/3, so we're going to plug that in. And then our n again was our 25, so 25 minus the 1. So then we're going to go through and we're going to just type that into our calculator as is. So 2 times 1/3, make sure the 1/3 we put inside parentheses, caret, and then 25 minus the 1 is just 24. So to the 24th power, and we get this answer right here. And this is just scientific notation, so we can round to the hundreds place, so 7.08 times 10 to the negative 12th power. We can just leave that as our final answer. If you're curious what this truly means, is we have 7.08 and then we are moving that decimal back to the left 12 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our decimal would go here, and then we would have zeros in all of these place values. So instead of having to go to all this trouble of writing this decimal, you can just leave it in scientific notation. And again, this is how it looked on the calculator with the e to the negative 12. So that just means 7.08 times 10 to the negative 12th power in scientific notation. For geometric sequences, again, make sure we remember geometric just means the pattern is multiplying or dividing by the same number. Sequence means our list of numbers are separated by commas. And make sure the r in the formula, we need to know what we're multiplying by. So if the pattern is dividing, we want to then take the reciprocal to see what we're multiplying by.